If we start with a question like, if I could save you £1 million a year on your ATM system, would you be interested? If we could add that to your bottom line. And if we could do that by doing less, not by doing more, would you still be interested? If I said all of this profit generation cost you less money to implement than the normal way of doing things, it reduced risk, it improved availability and therefore customer satisfaction all at the same time, would you stay for the next 25 minutes and hear about it? The objectives of the program are written out in longhand in a number of documents at the bank, but you can sum them up in two expressions: time to market and total cost of ownership. That's what we have to solve at Barclays. But clearly, when you launch a project of this scale, in itself, it introduces risk. It's a change on a massive scale. And the risk we're trying to avoid, both in our business as usual world and in this project, is ATM failure, the public face of ATM failure. And the key thing about ATMs and when they fail is that they transmit immediately to our customers and our competitors that we have failed in some way. The cost of maintaining an ATM system over, let's say, 5 years is 80% the cost of change. It's not the cost of buying it. And the largest cost of change is synchronization. It's synchronization of the activities of maybe 10 or 12 different departments in your organization. The reality, I believe, is the cheapest way to manage change is to plan for and implement almost continuous change. And there's a reason for that. It's like everything in life, you get better with practice. If you only change your system every 2 or 3 years when you absolutely have to, you're almost guaranteed to make a mistake. Where you do work is less important than what you do. And an awful lot of organizations look at the cost of an expensive process like testing, and it's expensive because they do it manually, and they say, I can get that done more cheaply elsewhere, where it has a lower mandate rate than New York or London or wherever it is. So what they do is they offshore to some location that is currently cheaper to execute the same piece of work. My argument would be, when you offshore like that, you take an old, inefficient and expensive, and as we'll see, incomplete process, and you relocate it to somewhere else where you operate that same expensive, slow, incomplete process for a lower mandate rate. My argument is, if you look at what people do, you can make orders of magnitude savings, not just marginal savings. How many test scenarios do you have in a real ATM system? Well, this is based on our current environment. I mean, as a rule of thumb, we have at Barclays roughly 5 authorization destinations that we send transactions to. We have roughly 5 card types, 5 transaction types, 8 card types we accept. Each of those destinations can respond with between 20 and 40 different response codes. So you do a little bit of maths very simply and you get 4,000 scenarios. If you looked at every single possible response code, you get 8,000 scenarios. That true situation that I just listed of 4,000 scenarios is what we would call happy path testing. By happy path testing, I mean every transaction you initiate gets a response. So we have 4,000 possible paths through our system in which we'll get a good response back. Not necessarily an approval, but a complete syntactically correct response. When we look at the unhappy path testing, which is what leads to those sort of embarrassing failures in the field, our Win-Nixdorf hardware and software can report 1,500 different events back to our system. I don't expect to see very many of those over the course of the system's lifespan, but I have to be prepared to see all 1,500 at least once. In order to test those, at least 1,000 of them can't be created by a man in front of the machine with a card. We dispense amounts between £10 and £250 at our machines using £10 notes and £20 notes, and that adds up to over 90 note mix combinations, another dimension of complexity. We use HTML presentation mode in the ATM, and we have up to 5 languages supported. That's 4,000 combinations of base HTML and overlays to make up that set. So you can see these numbers just keep scaling up and up and up. So even if you've got 250 people offshore at a low day rate, you can't achieve this level of testing in a manual environment. So what was our philosophy for approaching this? Well, we said, first of all, you have to accept the scale of the problem. Like most of life's problems, if you deny them, they don't go away, they just get worse. So the first thing we had to do was accept it. And what that meant was accepting the scale and the scope of the testing we had to do. And it meant not trying to fit our testing to the available resource profile. It meant coming up with a method for testing that fitted the test scope that was required. So if you've simulated all your endpoints on your hardware, then you can automate your testing. And this is where you achieve the coverage you need. We run 1,500 tests a day per virtual ATM using an automated system. And crucially, we run that every day, even when we haven't changed anything. And because the tests are running automatically from the very beginning of the life cycle, defects surface sooner. And because our dedicated specialist professionals are available to look at them immediately instead of at the end of a 6-week test cycle, defects get fixed faster. We have a philosophy that I would describe as change anything, test everything. And I think that is the opposite to most organizations. Most organizations, when they change something late on in a project particularly, they try and limit the testing to the very precise area they know they have changed. The problem is, when you change anything, you don't know really what you've changed in terms of side effects. So by applying all of our software changes from all of our vendors rapidly and then regression testing the whole system, we maintain a level of confidence in our environment. So right now we have 4,500 transaction test scenarios, and we can execute those in 12 hours. The cost for doing that manual testing offshore was predicted to be £1.3 million. £1.3 million to execute a manual test that we estimate was about 20% of the coverage we required. In 5 months, we built this harness, we licensed the products, we built the test scenarios, and we executed them, all in the UK, for significantly less than £1.3 million. Our payback on what we spent was 6 months. And every time we execute this harness now, we get 500% of the coverage we used to have, and we do it in 48 hours instead of roughly 3 months. Simulated ATM hardware, these are screenshots from our environment, running our real software build on a virtual machine. And it connects, that's in a product called Bridge Test, which I believe you can see in the demonstration area. And then we use a product called Versa Test, which is a standard message-based simulator which provides us with our issuer simulation. This environment will permit us to rapidly and completely retest the system in the business as usual world, and that will give us our faster time to market. It will allow us to reduce the risk compared to what we do now in making no change, make continuous change, and put ourselves at the forefront of the UK ATM market instead of at the tail end of it. This isn't something any one company can do. It takes cooperation between all of your suppliers to make this work, but all of your suppliers also benefit from this. We've accelerated the delivery of Winco and Nixdorf software to us by allowing them to use our test environment. As a result, they can test faster and more completely before they deliver to us, so they get fewer defects thrown back at them. So it's a win-win for suppliers and operators. Our expectations is that we will gain, from the project as a whole, not just from the testing, 2% improvement in our availability, which will take us to the top end of availability in the UK.